Now, don't be nervous, but there is a hole in our universe. Is it leaking? It's larger than anything we've seen before. The human mind can't even imagine something this huge. Well, mine sure can't. Is it a growing black hole? Is our solar system going to end up sucked music into this giant nothingness? Am I blowing this all out of proportion? Well, let's figure it out. The universe isn't packed evenly with stuff. Music, huge empty areas called voids, make up about 80% of it. Our own Milky Way even sits inside of one known as the local hole. But one void is on a whole different level. It's called the Boötes Void, and people often nickname it the Great Nothing. It's a massive, almost empty bubble of space located far away in the Boötes constellation. Its sheer size makes this bizarre formation unbelievable. The Boötes Void stretches music a whopping 330 million light-years across. For comparison, our little solar system has a width a bit more than 3 light-years. Yet, the Boötes Void contains very few galaxies. Compared to the rest of the universe, it's basically empty. That makes it one of the largest known voids and one of the biggest empty music spaces we've ever found. If our galaxy were inside the Boötes Void, we wouldn't have seen any other galaxies for most of history. Until the 1960s, our telescopes just weren't powerful enough. Other galaxies would have been way too far away and too faint to spot. It wasn't until the 1960s, when music telescopes got much better, that we could finally see very faint, far-away music galaxies. If we had been living inside that void, that's when we would have first realized other music galaxies even existed at all. But let's figure out a very important question. How do such giant empty music spaces even form? After the Big Bang, all the matter in the universe started spreading out. But it didn't spread out perfectly evenly. Tiny random differences called quantum fluctuations meant so. Me areas had a little more matter than others. The denser areas had stronger gravity, so they pulled in even more matter. Over time, this left other regions almost empty. That's how galaxies clumped together, and how huge voids were created in between. So over time, galaxies attracted each other too, linking up into long thread-like structures called filaments. Together, those filaments formed a massive foam-like web across the universe. The galaxies gathered along the threads, while the empty spaces in between became voids, kind of like bubbles and foam. Smaller voids slowly merged into bigger music ones, which is how enormous regions like the Boötes Void formed. Today, filaments and voids make up the largest structures in the universe. The filaments are hotter and more energetic, while the voids are colder and much emptier. Now, the Boötes Void is enormous. It makes up music about 0.35% of the diameter of the entire observable universe. But inside this music massive space, there are only about 60 galaxies, mostly stretched out in a tube-like shape through the center. Normally, a region this size would contain around 2,000 galaxies. The void is also surrounded by massive galaxy clusters like Ursa Major, Shapley, Hercules, Corona Borealis, and Boötes. This makes the emptiness in the middle even more shocking. Now, scientists first noticed those huge empty spaces and big galaxy groups in the music 1970s, when new technology finally let them see the universe in 3D. As for the Boötes Void, it was discovered in 1981 by American astronomer Robert Kirshner from the University of Michigan, which also has a pretty good football team. At the time, he and his team were mapping the universe in 3D by measuring how fast galaxies were moving away from us. This method is called a redshift survey. So while doing this, they noticed something weird, a huge region of space where almost nothing showed up. It was basically a giant blank spot on the map. Scientists ruled out a few dramatic ideas right away. The Boötes Void isn't a black hole because it does contain music, a small number of galaxies, just far fewer than expected. It's also not a dark nebula, which is a dense cloud of gas and dust that blocks out light. The Boötes Void isn't hiding galaxies. There simply aren't that many to begin with. The Boötes Void helps scientists learn how the universe changes and degrows. Because it's so empty, it's a great place to study dark energy. Our universe consists of normal matter, and dark energy. Normal matter is everything you can see with your own eyes or with the help of instruments. It makes up around 5% of the universe. About 27% of the universe is dark matter, and dark energy takes up around 68%. Music, it's a force responsible for the expanse ion of the universe. We really don't know what dark energy is, so scientists are excited about any chance to study it and learn more about how it works. Voids are also useful for studying neutrinos, tiny particles that can music travel throughout space without getting stuck. They're often called ghost particles because they're almost impossible to catch. They fly through space and through you without leaving a mark. Right now, trillions of them are passing through your body and you don't feel a thing. Neutrinos are made in places with lots of energy like the sun, exploding stars, and nuclear power plants. They are everywhere, second only to light particles in the universe. What makes neutrinos' music really strange is that they can change as they travel. They come in 3 types and He can switch music between them while moving. Scientists also don't know how much neutrinos weigh or which type is the heaviest. Learning more about them could help explain how the universe works. Well, anyway, with time, space missions will look closely at these empty regions. By comparing what they see with computer predictions, scientists hope to learn more about neutrinos and better understand how the universe works. One of such space missions is Euclid. Its data will be used to study and analyze the Boötes Void and other similar cosmic voids. Euclid's music job is to study the dark universe. It does this by making a huge 3D map of space, looking at billions of galaxies as far as 10 billion light-years away, and covering a big part of the sky. Now, scientists know that dark energy makes the universe expand faster, and dark matter helps galaxies form and stick together, but they still don't know what either of them really is. By watching how the universe has changed over the last 10 billion years, Euclid helps scientists understand how space grew, how galaxies formed, and what dark energy, dark matter, and gravity might actually be like. Euclid is about 15 feet tall and 12 feet wide. It has 2 main parts. One part runs the spacecraft like power, computers, and steering, and the other holds the telescope and 2 cameras. One takes pictures in visible light. That's what our eyes can see. The other sees in infrared light, which helps scientists spot very distant galaxies. Now, Euclid launched on a SpaceX Falcon 9 rocket from Florida in July 2023, and officially started doing science in February 2024. It now orbits far from Earth, nearly 1 million miles away. It stays in a special spot in space where it moves with Earth around the sun. This keeps its view stable and makes it easier to study the universe. Euclid is supposed to work for about 6 years, but it might keep going longer if it doesn't run out of fuel. In October 2024, Euclid released the first part of its huge map of the universe. Over time, it'll scan more than 1/3 of the sky outside our Milky Way galaxy, capturing billions of galaxies, some so far away that their light took up to 10 billion years just to reach us. The images taken by the space probe are about 4 times sharper than those taken by telescopes on Earth. Euclid also studies light in detail to learn what galaxies are made of and how they move. It'll do this for hundreds of millions of stars and galaxies, and all of this will create a massive space data library. Music, one of the biggest ever made by a space mission. Oh, by the way, Euclid was named after an ancient Greek mathematician who helped invent geometry, the study of shapes in space. Scientists picked this name because understanding the shape of the universe helps explain how matter and energy are spread through space. So now you know. That's it for today. So, hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright.